Hello, everyone. I'm Prathya Banerjee. I'm a master's in computer science student at UIC, and I've done a project as part of cloud computing, the CS441 course taught by Mark Grechnik. And this project is about I've built a large language model conversational agent using AWS Bedrock and Ollama. And as part of this project, we have used different services of AWS, such as API Gateway, Lambda, EC2, and we have also used Bedrock and Ollama, which is a product of Meta. So I'll give a brief overview of the project. So let me just go to the system flow that will help you guys visualize it more like due to this picture that I've created. So here are the different components of this project. So there's a client and there's a server, and then there's API Gateway, Lambda, Bedrock, and Ollama. So what we have done here is there's an AW like Scala client which calls the EC2 server like another Scala microservice. So these two are the Scala microservices, and we are using making API calls using the framework called akka. So we have used the akka framework to make REST API calls. So the client microservice calls the AWS EC2 instance, like the LLM server that is deployed on AWS EC2. And that instance calls API gateway. And through API gateway then trigger like invokes Lambda. And Lambda then calls Bedrock. And then the response comes when the response from Bedrock comes back, the client. The client then calls Ollama with that response of Bedrock. And then Ollama then gives a response on the basis of that query to the client. And that's how the client then again sends that response to the EC2 server. So that's how like a continuous conversational flow is happening between AWS Bedrock and there I've used the model Amazon Titan, and in Ollama I've used Llama 3.2, the 1 billion parameter model. So that's how a conversation is continuously happening between Bedrock, like AWS Titan hosted in Bedrock, and then Ollama. And the other things that like if I go into a bit more detail, what we have used in this project is like we have containerized the applications. Like we have used Docker containers to store the client and the EC2 server that has been the LLM server that has been hosted on EC2. And one more thing is we have used gRPC, like we have emulated gRPC to make a call to API gateway from the AWS EC2 instance, like the LLM server that is hosted on AWS EC2 instance. What I mean by emulated the call to emulated gRPC is like gRPC usually sends requests as protobufs, right? And there's a client and the server. So here, since the LLM server is calling Lambda, the like API gateway, like through it calls API gateway and then API gateway invokes Lambda. So the server basically should be API gateway or Lambda, right? And Lambda's main point is Lambda is serverless. So we can't keep the code of the server like for the gRPC server code in Lambda. That will keep like Lambda continuously running, and that totally defeats the point of Lambda being serverless. So what we have done is we have tried to emulate gRPC by we are sending an HTTP request, and then as the data that we are sending, we are sending protobufs in a serialized manner. Protobufs is the data structure that is used to send data in gRPC. So if I go to my code, that will help it explain a little bit better. So this is the conversational agent code. That is the server that has been hosted on AWS EC2 instance. So if I go to the API Gateway service, so here we have first created a for protobuf we need to define protofile and sorry, just a second. Uh, yeah, so we need to define a dot protofile uh, which is this lambda.proto. Here it gives the text generation request and text generation response. Like these are the data structure that it uses to send the request over the network. And here in the API gateway service, this is the service class that calls the API gateway. So here, if you see, we are using the text generation request, the protocol buffer message, and then we are serializing the request to a byte array, and then we are encoding it, and then sending it over to the API gateway. And in Lambda, we are like decoding the request body, then deserializing it, and then we are sending it over to AWS Amazon Titan, which is hosted on Bedrock. Yeah, that is the flow. Here we have tried to emulate gRPC. We are making an HTTP request, but we are sending like protobufs as the message. Like we are trying to emulate. We are not actually using gRPC, but we have emulated gRPC by sending like protobufs in a serialized manner. So now let's get started. A lot of theory I've explained, and now let's go to the demo. So this is the things that the services that we have used in AWS. So first is the Lambda function. This is the my Lambda function that I've created and which has a triggered the API gateway. So this is the my API gateway trigger. If I go into that, this is the API endpoint, and here you'll see this is the post request of the my API gateway like endpoint, and it is integration request, which is the my Lambda function. So one, if someone calls this API gateway, it will invoke this Lambda function, right? So that is it. And now let's move over to the AWS Elastic Container Registry. So this is the part where I've told you, right, that we have used Docker as part of this project. So here is the image that I've pushed, like the server image. So the client has been hosted locally. Like if I go back to the image, so this client that is hosted locally in a Docker container, and the EC2 server is hosted like the LLM server that it is hosted on AWS EC2 in a Docker container. All right. So I have pushed this EC2 image, like the LLM server image, like this conversational agent, the server, that image in AWS container registry. Um, Here, this is the image, and we will be pulling this image when we run our server on EC2. So let's do that. Let's go ahead and do that. So here is the power terminal, like PowerShell terminal where I have SSH to the EC2 instance, and then I have logged into AWS ECR as well. So I will run the command that to pull the image. This is the command that we need to run to pull the latest image, and then run it. Yeah, as you can see that it is pulled the image. Now we are good to go. We can run the server now. Sorry. Uh, yes, we can go ahead and run the server on AWS EC2. So as you can see that the server has now started on AWS EC2. And how we did this, we created an image and then pushed it in AWS ECR. If I show you, like, this is the Docker file. So the LLM conversation agent is the server, and the LLM conversation agent client, that is the client. All right, so we have two repos. If I go to GitHub, it will be a bit more easier to explain. So there are two repos, LLM conversation agent and LLM conversation agent client. So the LLM conversation agent is the server and LLM conversation agent client is the client, right? The client will be hosted locally and the agent we have just now deployed on AWS EC2 instance. All right. I'll just I'm showing the Docker file so that you guys get a better understanding like how we created the image. So this is the basic Docker file command. So we are first creating a work directory app, and then we are building the image. And then from after the image is being built, we are just creating the copying the src main resources application.conf files, and then building like the assembly jar and exposing the port 8080, because this is very important because this is the port that which we'll be calling from our client. And then this is the Java commands to run the jar. All right. Now let's go ahead and take a look at the client code as well. So this is LLM conversation agent client. So here also we have created a Docker file, uh, and basically the same commands for the client as well, more or less. It's just that we have to create a directory as well here, um, and because we will be storing the output there, and we have used another thing that called Docker Compose. So we have created two Docker Compose files in this project. All right. So one is for running it locally when both the server and client is running locally and another is when the server is running on AWS and the client is in the local. So how my project structure is like if I go to D drive, this is the LLM conversation agent that is the server. This is the client. And I've created a separate LLM deployment folder where there are two LLM compose files. One is for running it like the client is in local and uh, the server is on AWS EC2. So here I've mentioned the server URL as 8080, like EC2 instance, the EC2 domain name and then the port. And let me open the other one as well. And this is the second one when we are running it locally. Both the server and client is present locally. Here, if you see that in the services, the server is also mentioned, which here it's not. Here only the client is present. But to run it locally, you need the server and the client both running locally in separate containers. And the client depends on the server. And yeah, that's basically it. So these are the two Docker Compose YAML files. All right. So yeah, I just went through my code for the Docker part so that you guys have a better understanding of this. Um, and now, uh, where were we? We have started the server on AWS EC2 instance, and now we need to start the client as well, and we need to start Ollama as well. So let's go first. Let's start Ollama. So I've used Llama 3.2 1 billion parameters model, and as you can see, Ollama has started. And now we'll in another terminal. So here in this, we need to start the LLM client, like that will be running in a Docker container. We'll be using Docker Compose command to run the client, and we'll pass the argument. If you just take a look at the client, I'll just briefly go over it and I'll try to make it as short as possible. So the client is just basically it has a conversation manager class, and it first it calls the Bedrock, like Amazon, like the server, with the query that the user provides through command line argument. And then it gets a response from the LLM server, which is hosted on AWS EC2 instance. And then it forwards that response to Ollama. And then Ollama will again give a response based on that. And then the conversation manager, the client will again forward that response to the LLM server or to Lambda, to Bedrock. Like that, a conversation will keep on happening, and it will happen the maximum of 5 times because that is what the maximum turns have mentioned. So you can increase it, decrease it as per your wish. And now I'll try to run this command. And as the argument, I've just passed how to stay happy. So this will be the first command that like the first string or prompt that will be sent to the LLM server, which will then call API gateway, then Lambda, then Bedrock, Amazon Titan to be precise. So if you see that the client is running, and the client has forwarded the server the request. And if we go to the server has also received the request how to stay happy. And this is how like the server will send the response. Here, if you can see, these are the logs. Bedrock has like this is the how to stay happy, like which the user has provided. Like I provided that to the client, and then client forwarded it to the LLM server. And here, the Bedrock has mentioned get enough sleep and all those things, get enough eat a healthy diet, and which is then asking the model Ollama uh, to like it has forwarded the response it has gotten from Bedrock to Ollama, right? So this is the prompt. If you see that this is the exact response that Bedrock sent. So it has forwarded that prompt to Ollama. And if you are wondering what are these options, num predict, temperature, top key. So these are the like the maximum. Num predict is the maximum number of tokens. So I have only given 50 tokens. So like Bedrock and like Lambda can sorry, Ollama can send at max 50 tokens as a response. So after that, it will like break it off, like only 50 tokens are permissible. So here, if you see that Ollama has given a response, and then again we are sending that response to Bedrock, like received server response. So we have Ollama has given a response, and then we are calling the server with this query that which Ollama provided. And then again, Bedrock has given some response. So this is how the conversation, if you see, has kept on going. And this is a big conversation. And if you see, the conversation ended after 5 turns, right? Yeah, if you want to, let's see the output, we'll get a more clarity what the exact conversation was. So in the output directory, this file got created, conversation log. If you see, this is the first query that I provided. And then Bedrock responded that how to stay happy, get enough sleep, exercise regularly, eat a healthy diet. And then Ollama's response to that was prioritize sleep, then aim to 7 to 9 hours of sleep per night and all that things. And if you see, turn to the query was the same thing that Ollama responded. So the client forwarded the exact query that like the exact response that Ollama provided to Bedrock. And then Bedrock again uh, said that if you see, the interesting thing is here Ollama's, that's why I was telling the maximum number of tokens I allowed was 50 tokens, right? So here if you see that after some time Bedrock, like this is the maximum response that it sent. It broke off, like create a relaxing bedtime routine to signal, right? It broke off after that because I said that maximum tokens response you are sending it to me can be 50. So then, and this is the response that we are sending. This is will be the query that we'll be sending to Bedrock, right? And so Bedrock has now completed the sentence which Ollama couldn't. Bedrock is now saying create a relaxing bedtime routine signal to your body that it's time to wind down and avoid caffeine, practice relaxation, and all these things. And then this thing is again sent to Ollama, and this is how the conversation flow is happening between uh, Amazon Titans, Bedrock like model, and Llama 3.2, which has been hosted on Llama. So yeah, that's basically it. So I'll just go through the diagram once again. So the entire flow once again, basically. So the client, it's just taking the query from the user to the command line. Then it is sending it to the LLM server hosted on EC2, which then makes a pseudo gRPC call, like sending the data through protobufs through API gateway. API gateway is then invoking Lambda. Lambda is then calling Bedrock. And then Bedrock is sending the response to Lambda, and then this response is coming back to the client. And then client is calling Ollama with that response. Right here, if we saw that the exact response that we are getting from Bedrock is forwarded to Ollama, and then the response that we are getting from Ollama is being forwarded to Bedrock. So yeah, that is basically it. And we have used Docker containers for the client and server. And these are the Docker files for the client. This is the for the client, and the for the server as well. It is present, and we have used Docker Compose as well. So yeah, that is present in this directory. So I'll include all these things in the repository. There will be two repositories. One is for the client, and one is for the server. But yeah, I'll include these the reports in the repository as well, and the Docker Compose files. All right, thank you. Please let me know if you guys have any questions. Thank you.